Hello students, so let us begin our practical classes. So today I'll be doing only 4 problems, basically to illustrate convergence and divergence of sequences, and we shall be using SageMath for the practicals as done in the first semester. So let us have a look at the problems for today. This is the first problem to plot problem number 1. So in your practical notebook you can write it this way. Problem number 1, this you may write, the aim of the problem is to plot the convergence sequence xn where xn is equal to 1 by n. Okay, it's a very famous convergence sequence. So when you begin the experiment, you just write these lines as well. The sequence 1 by n converges to 0. And to illustrate the convergence, we plot the points of the sequence using the following Sage code. Okay. So as I had explained how to write these things, so you have to write these code, say the questions part or the aim of the experiment part using markdown menu. Okay, so you select markdown from here and write it this way. So using 1 hash will give you a large heading, using 2 hash will give you a smaller heading. Okay, using 3 hash will give you a still smaller heading. Okay, and you need to enclose this within bracket in order to get the mathematical format x underscore n. Okay, so it will give n in the subscript. Okay, this is the LaTeX format, and you have already done this in first semester. So in order to write the fraction, we need to use this code /dfrac /dfrac. Then within braces you have to write this is the numerator, and within the next brace you have to write the denominator. Okay, so it will be displayed as 1 by n. Okay, then similarly to write the angular bracket for the sequence, you may use this code /left/l angle. Okay, and then you may give space here also, /dfrac 1 by n /right angle. Okay, so it will enclose your sequence within angular brackets, right? And then you press shift enter, you will get this type of display. Okay, then next you have to write the code. So you start with an empty graphics. Okay, because we need to plot many terms of the sequence, so we have to use a loop structure. Okay, so loop was also done in your course. In the first semester we have done loop. So we will use a for loop here. So first we will assign the empty graphics code to the one variable p. Okay, and then we will ask the user for input. How many terms does the user want to plot? Okay, so we will write it as this. This is something new that you have got this time. N equal to input, how many terms do you want to plot? Okay, so it will ask the user, or means when you run this program, it will ask you to enter the value of n. Okay, and this is what it's doing, and it will store that particular value in the variable n. Okay, and after that we have to use the for loop. So we need a variable here for I, so we use the variable I. That means for I equal to 1 we get the first term, for I equal to 2 we get the second term. Okay, I equal to 3 we get the third term, for I equal to 4 it's the fourth term, right? That way. So for I equal to n we get the nth term, right? So we have to write it for I in S range 1 to n plus 1. Why n plus 1? Because S range 1 to n, or say S range 1 to 10 will give you the values from 1 to up to 9. Okay, so one less. So if I want to plot the n terms, so I have to take S range from 1 to n plus 1. So that will give the values of I from 1, 2, 3 up to n. Okay, so for I in S range 1 to n plus 1, then followed with one colon, p takes the value of p plus points I comma 1 by I. Okay, so we have to plot the points whose x coordinate is I and the y coordinate is 1 by I. Okay, because the sequence is 1 by n. Okay, so for I equal to 1 it is 1 comma 1 by 1. For I equal to 2, that is the second term is 1 comma 1 by 2. Okay, that way. So x coordinate is I and y coordinate is the term of the sequence. Okay, and then you have to go outside the loop and write p. Okay, so what is happening, we start with an empty graphics p. So empty graphics means only the graphics, say the axis will be there without any plots. Okay, and on that empty graphics we start putting points. Okay, so for I equal to 1 we get the point 1 comma 1. Okay, so that is plot here. For I equal to 2, on the previous plot we put the point 2 comma 1 by 2. Okay, so that is what is happening. So that is the work of this loop, p equal to p plus points of this. Okay, so points will keep on adding in the earlier plot that was created. Okay, so for I equal to 1 the first plot was created, the point 1 comma 1. Okay, so when we go to I equal to 2, on the earlier plot another point will be plotted, that is 2 comma 1 by 2. Okay, then so we now have 2 points in the plot. For I equal to 3, another point 3 comma 1 by 3 will be plotted. Okay, earlier 2 points will remain and a new point will be plotted. Okay, so this is what is happening in the loop structure. So let us run this. How many terms do you want to plot? Say I want to plot 10 terms. Okay, so once you run this you will get this plot. Okay, see, for n equal to 1, I equal to 1, this is the point. Okay, for I equal to 2 it's 0.5. okay, it's here, this point is 0.5, right? For I equal to 3, 4, like that. Okay, so as you see the terms go on decreasing. Okay, so it's a decreasing sequence. But to illustrate the convergence we need to watch, or we need to have a look at some more points. Okay, so let us plot say 150 points and see how the points converge towards the limit. Okay, so 1 by 2, 1 by 3. Okay, now you see a better illustration. Okay, so as the number of terms increase, okay, 1 by n goes towards 0. Okay, so this is what is happening. So this is an illustration, right? So yeah, so let us see it for any some more points, say 300 points, and how many terms do you want to plot? Okay, so I want to plot 300 points. So see, this is the illustration. Okay, so as n increases, the value of 1 by n becomes very close to 0. Okay, so this illustrates the convergence, right? Okay, the next problem that we will do is to plot the convergence sequence xn, where xn is minus 1 to the power n by n. Okay, so you know from your knowledge of sequences of first semester, as well as second semester, the sequence minus 1 to the power n by n converges to 0. Okay, so in real analysis you have done this. Okay, so let us see. So you will write the things as it is in the practical notebook. The sequence minus 1 to the power n by n converges to 0. To illustrate this convergence, we plot the points of the sequence using the following Sage code. Okay, so let me just show you how you can write this in LaTeX code. So this is the LaTeX code we have used, /left/L angle, just like the previous one. Okay, so you can write it that way. So in the copy you just write it in language. Okay, and while running the program in your computer or in the SageMath cloud platform, okay, you use this type of codes, then the things will be displayed properly. Okay, right, so this is the same thing, the same program. P equal to empty graphics, then n equal to input, how many terms do you want to plot. For I in S range 1 to n plus 1, p equal to p plus points I comma minus I to the power I minus 1 to the power I by I. Okay, this one. So let us see how many I want to plot, say 50, right? So now you see how this sequence looks like. So this sequence actually for I equal to 1 it's -1. So you see here for I equal to 1 this is your point, okay, -1. Then for I equal to 2 it goes to the positive side. For I equal to 3 again it comes negative, okay. So it keeps on oscillating this way, but this ultimately converges to 0, okay. So even though there is some oscillation in the oscillation ultimately goes towards 0, okay. So this is also a convergent sequence. Say I want to plot 100 terms, okay. So you can see how you can plot 100 terms, okay. Suppose you want to separate the year points, odd and even terms, right? So you may use one if statement here. If I% 2 is equal to 0, that means if I is odd, I is even, okay, I% 2 will give you the remainder when I is divided by 2, okay. So if the remainder is 0, that means I is an even number. So if I is even, I want to plot the points using a different color, okay. So say color equal to red, okay, else just plot the points as it is, okay, by the default color. So default color for SageMath is blue, okay. So just remove that. So I just want to separate the odd and even terms, okay. Let us see how it looks like, okay. So you can understand this is a illustration, odd and even terms, okay, how they are changing, right? So that also you can do. You may write this code as well in your program, okay, in your notebook, okay. Another problem that we'll do is to plot the divergence sequence -1 to the power n, okay. So -1 to the power n, you know, it's divergent, that is not convergent. It actually oscillates finitely between -1 and 1, okay. So the -1 to the power n has two subsequences which converge, okay. One of them converges to -1, another converges to +1, okay. So since there are two subsequences which converge to two different limits, so the original sequence is not convergent, okay. Because if it is a convergent sequence, any subsequence of that sequence will converge to the same limit as the original sequence, okay. So if we are able to get two subsequences which converge to two different limits, in that case the sequence is not convergent, okay. So this is also the same thing. Print how many terms do you want to plot, okay, -1 to the power I. So p plus points I comma -1 to the power I, okay. So we can do it this way and see how this works. Say 50 points I want to plot, right? So how many terms do you want to plot? 50. So this is your, let me just reduce the size. Okay, yeah. So this is your plot, -1 to 1. So it keeps on oscillating between -1 and 1, okay. Another problem that we'll do is to plot the divergent sequence xn equal to sin n, okay. Sin n is also a divergent sequence, but this is a very interesting diverging sequence, okay. If you plot the points, you'll understand. To illustrate this, we plot the points of the sequence using the following Sage code, okay. So p equal to graphics, empty graphics, n equal to input, how many terms do you want to plot, okay. All are the same things. So p equal to p plus points I comma sin I, okay. So if you just run this, say I want to plot 50 points, okay. So you see the points are scattered, okay. The points are scattered. So I want to plot, say, some more points, say 500 points, okay. You'll see how interesting it looks like. 500 points, yeah. So see the scattering of the points, okay. So the sequence doesn't show any sign of convergence, okay. There is lot of oscillations in the sequence. Okay, so these are the 4 programs for this first class of practical. So please write these programs in your systems or in the SageMath cloud platform, those who are not having it installed in your system because of some problems. So please write these programs, and just as you have done in the first semester, plot these graphs on one side of the paper. Okay, and yeah, you plot it manually. Okay, so try to plot manually and neatly and clearly. Okay, so and for this one, okay, you will find it quite difficult to plot problem number 4. Okay, but still you try with not 500 points, maybe some less points. Okay. And yeah, so please try to illustrate your artistic mind, okay, in plotting this particular sequence, right? So we will see some more problems in the next video. Thank you.